All right, I'm going to do a few problems from our 10.1, 10.2, 10.4 review, and I'll start with the R2DI. So that is this problem right here. So we're going to write a Cartesian equation for the parabola in figure 10-8a, which is over here. Now, when I look at this parabola, I notice that, first of all, it's opening in the x direction. So it's not opening up or down. It's opening on its side. So it's opening in the x direction. It's got a vertex at 8, -2. And it's got an x-intercept of -4, 0. So I'm going to write that stuff down. So that's always my h and my k. It's also got a x-intercept, or another point, of -4, 0, which is going to help me. And then I noticed it opened in the x direction. Now, by heart, you should have the opening in the y direction form of this memorized. So we had learned in Algebra 2 that basically opening in the y direction, or up and down, this would be your vertex form. And there's a couple ways to kind of think about then opening in the x direction. It's basically the exact same thing, but the most important thing is that, your x and your h have to stay together, and your y and your k stay together. Now, I know it doesn't really look like that here. I think your textbook, this textbook, actually writes it like this. So you can basically write something very similar for when it opens in the x direction. And if you didn't know that, well, your 10.2 notes, Cartesian equations for conic sections, on the second page, down here for parabola, you have some options here. So, opening in the y direction, there it is. Now, when we wrote it, we just always put the k on the right-hand side. So at the very end, we just added plus k. They put it in the front. Or you can move it over to the other side and keep it with the y. Opening in the x direction, basically the equation's x equals. Now again, now the y and the k are going to go together, right? Because that's the vertical translation. So it goes with the vertical coordinate, makes sense. And then you can either put the h out here, or you can bring the h over here. So basically, it could look like this. You could think to yourself, I want the h with the x, and then the k and the y need to go together. And because it's opening in the x direction, we've basically got x not being squared. Or you can think to yourself, I want it solved for x, so or like I said, you can put the h over here. Okay, but basically this is the equation that we're going to be using. So I'm going to plug in, let's see, I'm going to start by plugging in my vertex. Or to simplify that, okay. Problem is I don't know what my dilation factor is. So in order to figure that out, that's why they give you another point. So you can plug in, this is my x, this is my y. I can plug those in and I can figure out what a is. So we got -4 equals 8 plus a times 0 plus 2 squared. Okay, subtract the 8 to the other side, I get -12 equals, and then really this is going to give me 4, right? Because this is just 2, so 4a. Or a equals -3. And now I'll just take that a and plug it back into my equation. So your final equation here is x equals 8. I'll put negative, so -3 times y plus 2 squared. Now, you might say, well, this would be really challenging to check graphically. And that's true. I mean, you could solve it for y and get some crazy equations. I think you'd get 2 and you'd have to plug in a positive and a negative. Or, since you're at home right now, you could go ahead and use, let's see, Desmos, right? So you can type in, Desmos is really user-friendly. You can just type in x equals, you type it exactly in. You see that this matches exactly, right? My vertex is at 8, -2. My x-intercept is at -4, 0. So here's our final answer. Okay, next I'm going to do R4B. So let's look at that problem. All right, so you have a paraboloid. It's formed by rotating about the x-axis. The part of the parabola, x equals 4 minus y squared. Let's just talk about that parabola for a second. So x equals 4 minus y squared. So that piggybacks right off of the previous equation that we were working with, right? So we've got a parabola opening in the x direction. And if we compare it with basically the vertex form opening in the x direction of a parabola, then we can see that my h is 4, and I don't have a k, which tells me that my vertex of this thing is at 4, 0. I also happen to know here that my, let's see, my a is a -1. Okay, so what's the difference between a being positive and a being negative? Maybe you're asking yourself that question. Well, luckily we have Desmos here to help us. So right now, here's my equation of this parabola opening in the x direction with a -1a, or a negative a. Well, what happens when I make that a positive? And there it is. So basically this thing now is flipped, and it's opening in the positive x direction. So when you have a negative a, it's going to reflect basically over this y-axis. Just like whenever we had, when it was opening up and down, if we had a negative a, it was reflected in the x-axis. Well, now because it's on its side and opening in the x direction, this negative a will reflect it in the y-axis. All right, moving on. Let's see, where am I? Actually, let's go back to the problem. Okay, so then we've got, so basically what they're saying is they're taking this parabola and they're rotating it, so you can kind of see how you get this, like, paraboloid. A cylinder is inscribed in the paraboloid with its x-axis, with its axis along the x-axis. So that's telling me that its height is parallel to the x-axis, and its left base containing the origin. So this left base right here, I can kind of think of the center of it at the origin. Find the radius and altitude of the cylinder with maximum volume, and then find the maximum volume. All right. So I'm going to draw this picture. I'm going to draw a really bad picture, but I'm going to do my best. And I encourage you to always draw this out. So we've got this parabola that I know goes to 4. Pretend like I did a really good job with that. And then within that, I've got an inscribed cylinder, the base being kind of centered at the origin, and then something like this. Where basically my height is now parallel to the x-axis, and my radius is now parallel to the y-axis. So on this point here, I've got some point on this inscribed cylinder, x, y, and I know that the equation of this paraboloid, I'll just write it down here, is x equals 4 minus y squared. Okay. Now I'm trying to maximize volume, and I need to figure out the radius and the altitude when I'm maximizing my volume. So the first thing I want is a volume formula. So basically the volume of any cylinder is the area of the base times the height. So it's pi r squared times the height. All right, now the problem is I don't know what my r is and I don't know what my h is. I don't have like absolute values for them. But what I can do is I can write both r and h in terms of one variable. So let's see, my radius is y. So I'm going to go ahead and say, okay, my volume is pi times y squared. And then my height is x. Notice x is also in terms of y. So now I can just go ahead and put times 4 minus y squared. Right? So my height is actually my x, right? It's my x value. It's my horizontal coordinate. And then my r is my vertical coordinate, or my y. And I had a value for x in terms of y. So I just went ahead and put all that in there. Okay, and from here it gets really simple. You don't even have to simplify that if you don't want to. You just go straight into your calculator. You say, great, I'm going to graph this and I'm going to find my maximum. We'll go y squared. I'm going to use x squared. And then 4. And I know I want a positive x, so I do not want a negative x. So let's see, this is going to be my maximum. Sure, I'm on the left side of it. Let's go over to the right of it. And I get 1.414. Okay, so the max happens. So actually, let me go ahead and just put my maximum volume, which is 12.566. When my radius is 1.414. Now again, my radius was my y. So now how do I find my height? Well, the height is the same as, again, my x. And x is really 4 minus y squared, which is my y. My y was my radius, right? So instead of putting 4 minus y squared, I'm going to put 4 minus 1.414 squared. Which is approximately 2. And actually, I should have an approximation for my radius too. All right, so I get a max volume when my radius is this, and when my height is that. Next, I'll answer R2B double I. So you are given this ellipse, and it's given to you in center radius form, and they want you to transform it into polynomial form. Okay, so we're going to do a whole lot of multiplying here. So the student that asked this question, the first thing that student did was this. Oops, not 4. We have to square it. I'm just basically squaring top and bottom. Now, in my opinion, the best thing to do here is to probably clear our fractions. I don't know what the least common multiple for 49 and 16 is. So let's see, 49 is 7 times 7. I think it's just 49 times 16. I think that's all you're going to be able to do. So 784. So I'm going to clear my fractions by basically multiplying both sides by 784. Or probably an easier way to think about this is I'm multiplying both sides by 49 times 16, which happens to be, so this side I'll actually multiply by 784. Now, why did I write it like this? Well, because when I distribute this product over here, the 49s are going to reduce, and I'm just going to be left with 16. So I've got 16 times x minus 2 squared. And then when I distribute this over here, the 16s are now going to reduce, and I'm going to be left with 49. So it's 49 times y plus 3 squared. All right, so the pain now is that it's really not that hard, but we basically have to multiply out these binomials that are being squared. Hopefully you've got that kind of memorized in your head by now, but if not, I'll kind of walk you through it. Square the first term. Multiply the two terms, which gives me negative 2x, and double it, so negative 4x, and then square the last term. And I'm going to do the same thing over here. Square the first term. You can also double distribute, but by this point, you want these to start getting easier for you. You want to do this a lot quicker, if possible. Multiply these two together, 3y, double it, you get 6y, square the last term. And if you don't recognize that as a binomial squared gives you a perfect square trinomial, go back and visit with your friends for a little while. Okay, so now I'm going to distribute, so I get a 16x squared, a negative 64x, a positive 64. I got a 49y squared. I don't know what 49 times 6 is. 294. And 49 times 9 is 441. Okay, we need to have this thing equal to 0. Okay, so I'm going to move the 784 over. That's in standard form, right? You guys are used to polynomials being in standard form. Let's see. At the same time, do I have anything I can combine? It does not look like it. So let's see. We go. Do we have any x, y's? No. We got a y squared, though. Okay, so we're going to go 16x squared. We got a 49y squared. Then we got a negative 64x. A positive 294y. And then I'm going to combine all my constants. So I have this 441 and 64. And from that, I'm going to subtract 784. So negative 279, it looks like. That should be in polynomial standard form. I'm going to double check my answer here. R2, B2. Yep, look, that looks good, I think. 49y squared minus 64, 294. Looks good.